I need from you guys is to take out your practice tests that I gave you guys. Yeah, I'm listening.
When I didn't bring my backpack today, you know what I did put in my bag besides my tablet?
Your practice test.
That's all I grabbed.
Nice. Well, you chose wisely.
I looked at it and I thought, yeah.
Yeah, that was the plan for the next 2 days, is to just talk about stuff from the practice tests. So if you guys can pull those out and find your paper ones, we're going to start with questions from yous from paper one. Sam, we're taking out our practice test and finding paper one. And we're going to start with questions from you guys from paper one.
That was so rude, Sam.
So take a minute and flip through, but as soon as you have something that you're like, I want to talk about this one, holler at me and we can start. Olivia's up first. 11 together, sure.
Special delivery.
Oh, thank you.
So this is just for you. So
Just
not your
for me.
kids, they got enough.
Okay, thanks.
Yeah, I know. Especially we're in the middle of Pontiac. I don't know if you decided that. We come here every single day to work.
Yeah, and there's security and it's light out. It's gonna be 3 a.m. trips.
Well, I think the bigger issue is like last week when I was coming in the morning, I saw a coyote running down by the creek. Yeah. So I would recommend not camping out unless you have coyote contingency plans.
I could trade it.
Good luck. Good luck. All right. So number 11. The question asks us to find the length of BQ. So it's asking for this arc. So I remember the arc length formula. Now that's in the packet, but if you look at in the equation packet, but it's the way they represent it is super dumb and like not very helpful in my opinion. So the way that I'm going to write it, so the idea is I'm going to take the central angle intercepting BQ, so that's angle BOQ, divide it by 360, and then multiply it by the circumference of the circle. So it's just like proportional to the circumference of the circle, right? It's just like, oh, that angle is this percent of the circle. Well, then that arc is that same percent of the circumference. So in order to do that, I'm going to need two things. I'm going to need angle BOQ, and I'm going to need R. Maybe I'll use two different colors there. So to find R, I noticed that BO is the radius, right? Everybody's okay there? So BO is just the hypotenuse of that right triangle. So it's the square root of 89. I think that's a point. There's 5 points for this problem, it says. Right, it says 5 marks. So that's probably 1 point right there for finding that. So we got R. Everybody feel good? Now we need to find the angle BOQ. So what I did when I did this is I said, okay, well, that angle is 180 degrees. And this is a right triangle. And if I subtract that angle, that's going to give me the leftovers would be BOQ. Does that feel okay, Olivia? Alternatively, you could have gone over here and you could have done like 90 plus BOA. It's basically the same problem. And that's going to equal, that'll also equal BOQ. You see what I'm saying?
Yeah.
So you could do it that way also. It's equally trivial. The question then is just like, oh no, I only have a new thing to find, this angle BOP. So we got to find BOP there. The good news is that this is just a right triangle. And I know the side lengths because I'm told that AOCB is a rectangle. So angle BOP is just going to be tan inverse of opposite over adjacent. It's like 3201 when I type that into my calculator. I'm looking for this angle in here. Is that good enough? Okay. Anytime you're looking for an angle, you're using the inverses, right? And I know the opposite and adjacent sides. So, tangent. So now that I have BOP, I can plug that in. So I have the green, and now I have the blue, and so we can stick them both together. And it's just calculator time at that point, right? Let me look up what that was real quick. $24.4. So if it's me and I'm filling this out, or I'm writing my work down on my IB exam, this is what I'm going to do. Notice that I'm not circling any answers. I don't want to announce to whoever's grading this what I think my final answer is, because if I have the correct answer somewhere in here and then I go past it and do something else or make a mistake after that, I will still get the marks for having the correct answer if the correct answer's on there, even if I do too much afterwards or make a mistake later. So I am not going to circle any answers. I'm not going to label like which parts of the problem I'm working on. I am just going to write down stuff and let the grader kind of sort it out for themselves. Now, I want my work to be clear. I want it to be linear, but I'm not going to announce what I think the answers are. I'm going to let them find the answers in there and be like, okay, they got this, they got this, they got this, they got this. That's all the marks they need. I don't know what all this other stuff is for, but they got what they're supposed to have, so I'm going to move on and give them full marks here. Is everybody okay with that? Just as a test taking hint or tip. So I would probably not even include like these things. This is just for you guys, right? As to what I'm doing. So if I go and I look at the mark scheme for this problem, let me pull that up real quick. Let's see where those 5 points happened. So we used BOP. So there is 1 point for getting this radius, the square root of 89. 1 point for calculating BOP. 1 point for plugging 1 point for plugging in that angle. Oh, I guess we use BOQ, but we did it a different way than they did. It doesn't really matter. 1 point for calculating the angle. 1 point for plugging the angle in the arc or in the radius into the formula. I guess there would have been another point for when we did when we subtracted 180 minus BOP to get BOQ. And then 1 point for your final answer. So again, lots of places to pick up even if you did something wrong. You know, like if you showed, like my suspicion is if you have this written down, like that's a point. You make that observation of like how you're going to find angle BOQ, like that would be a point. You know, the radius was a point. That's 2 of 5 already. You're sitting at 40% for a problem maybe you didn't feel that great about. You know, and I think even if you plug the wrong numbers into this, if you find 2 numbers and plug them in, I think that would have been a 3rd point. So now you're sitting 60% on a question that you didn't feel great about, and you're living in 4 or 5 land on this one particular question, which is if we feel we can get 4 or 5 mark or a 4 or 5 score on a question we don't feel great about, and we kind of crush the ones we do, you're looking real pretty on this exam. So, Liv, do you feel good? Mm-hmm. And again, for this, I think the hardest single thing you had to do for this is making the observation that BO is a radius. That would have been the hardest thing. So when you're doing any of these IBSL problems, none of them are going to be crazy complicated. So if you start thinking like I have to do like some crazy complicated thing, you've missed something. You've missed something that makes the problem easier. So go back, read it again, look at the picture, think about what you need. Don't get stuck on like PO or OQ is the only radius, right? Like, so maybe there's a part that you can draw in that's easy to find that is also the same length or whatever. All of these problems, the calculation, the work to solve them is going to be either done entirely with your calculator or be relatively easy, like 1, 2, 3 steps. And the only time you're going to see a 3-step thing is if you have a 5-mark question. Like if it's 2 marks, it's going to be like write an equation and solve it. Like that's it. That'll be the 2 marks. 1 point for the equation, 1 point for the answer. Like if you're trying to do something crazy on a 2-mark question, you've missed something and you're doing too much. There's some given that you missed. Who's next? What else should we talk about? Let's stay in paper 1 for a few more minutes anyway. What's that, Sam? Oh, Walt Jr.?
Yeah, well.
Number 7, you said? 10. Sure. All right. It says, when studying big cats, researchers use a model in which the mass M of an animal is directly proportional to the cube of its shoulder height, h. A cheetah has mass of 64 and shoulder height of 0.8. Use the model to find an expression for M in terms of h. All I have to do is translate that into an equation. It's told me the answer right there. So I'm going to say the mass is, so M equals, directly proportional means like there's a constant K times, and then the cube of its shoulder height, so H cubed. Everybody okay with how I translated that sentence into an equation? Directly proportional just means it's K times whatever. Okay. We still have one more thing to do. So that's 1 mark, I suspect. The second mark is going to be figuring out what K is. That's what this piece is going to allow me to do. So I'm given a mass and a height. So then I just divide both sides by 0.8 cubed. And I'm going to get K is 125. Joe?
Why is there a K? Isn't it asking just for part of the assessment
So AI says use the model, find an expression of M in terms of H. So M and H should be the only variables in it. That's why we're finding the value for K here. So the directions are telling you it should have only M's and H's. Those should be the only letters. So I needed to figure out what K was. In part 2, then, we're going to use that to make a prediction. Olivia? Yeah. So part 2 says, hence find the mass of a cheetah whose shoulder height is 0.75 meters. So I'm just going to plug it in. That's it. So that comes out to 52.7. And again, I'm not going to circle anything on my test. Sam, feel good so far?
Yeah.
Okay. Then it gives us some more information here. It says, Rubner's law states that the energy needs of an animal, E, are directly proportional to the square of H. The energy needs of a lion of mass 220 kilograms are K times the energy needs of a cheetah of mass 64 kilograms. Hence, find the value of K. So what I'm going to do is I'm going to start by using this. So we're told, again, E is directly proportional. I'm going to make like a subscript on this K, so it's a different K than the first K, to the square of H. So E equals, I'll call that K1 squared, or you call it K bar, or C, or whatever letter. Everybody okay with that? All right, and then the next piece says the energy need of a lion is 220 times, or 200 of mass 220 kilograms, is K times the energy need of a cheetah of mass 64 kilograms. So I know that the energy needs for a lion is like that. Oh, let's say, I'm sorry. Is K times the energy needs for the cheetah. Sorry, let's say that. And this guy is what we're trying to solve for in the question, right? That's the K that we're talking about. So if I divide both sides by EC, that K is going to be, I'll just call it K, is the energy needs for the lion divided by the energy needs for the cheetah. So the energy needs for the lion is going to be that K1 times the height of the lion squared over that same K1 times the height of the cheetah squared. But I'm not given the heights of the lion or the cheetah, right? What am I given instead? The masses. So to solve for the mass, or to solve for the heights of the cheetah, I know that the mass of the lion is K times the height of the lion cubed. So the mass of the lion was 220. The K we solved for in part before was 125. H cubed. So the height of the lion is going to be the cube root of 220 over 125. And then we know the mass of the cheetah is K times the height of the cheetah cubed. So again, the cheetah was 64 kilograms. The K is still 125. So the height of the cheetah is going to be the cube root of 64 divided by 125. Squared. And when I punch that all through, I get like 228. Let's look at the mark scheme on that one. That last part was 4 points. Let's figure out where those 4 points were coming from. Yes. Oops, wrong paper mark scheme. All right, let's see.
And my back hurts. Oh my god. Yeah.
Okay. So it looks like 1 point for writing this anywhere on your paper. 1 point for calculating the height of either one of these things. In our case, the way we did it, we calculated both of them. And then, where was that? 1 point for plugging them in, and then 1 point for your final answer. So 1 point here, 1 point for either one of those, 1 point for the plug-in, 1 point for the final. So again, the bigger point question here had to do quite a bit to do. But 1 point was basically free just by translating, this piece in green into an equation. That was a point already. And then the next point I got by just like converting these masses into heights using our answer from part A. And then using this thing using the thing in blue, I wrote a second equation, solved for K, and then plugged in my heights for my last 2 points. Henry, go ahead. Are you trying to go someplace? Oh, okay. You had that paper in your hand like you're itching to go someplace to get rid of it. Olivia, you're shaking your head. You don't look happy.
No, but so like you don't necessarily have to for these. You don't necessarily have to like do it like one way.
Correct.
Yeah.
Yes. Yeah, in fact, if you look at the mark scheme, I think for this one, they had a couple of different ways you could go about doing it. And in fact, I think even the way that I went ahead and did this doesn't exactly match either their methods. but I'm certain that I would get full marks for it because I had the correct answer, and the work I did is like, there's nothing wrong with what I did, and I get the same answer. So I just think the way I did it was much clearer than what they did here, because it just like, I don't know, like some of the stuff I'm like, I don't know where you got, like where did this 0.8 come from? I don't know where that came from. And I know where it comes from, but they didn't have it written down anywhere here. That's the height of the other animal. So it's like, it's exactly what we did, but this has like I have way more work shown than what they have written down here. You know what I mean? So I just like, maybe I see, no, I still don't know. I'm not sure. And they did something else here with like using a cube root and like plugging stuff. I don't know. Like, I think that what we did was pretty straightforward. And I think is probably what the person who that wrote the question, what they would have wanted you to do to solve this, not necessarily what the person who solved it did. So I don't know. But I liked it because I felt good because I had to use the equation that I wrote in part A to do this. So I felt real good about it, right? Like that's how I got those heights to plug in here, was because by using the equation from part A and the given masses, I just plugged those in to solve for the heights. What else should we talk about here? We talked about this one in 5th hour. And I thought this would be a good one to talk about because you can use your calculator to do the entire thing. I showed you how to do it by hand on my Kulik key. But this is one that screams, I can do this all on my calculator. So just kind of a reminder here. If I have a trigonometric function, there's a couple of key features. So there's an amplitude, there's a midline, and there's a period. You guys kind of remember geometrically what those things look like by looking at the graph? It's not super duper necessary that you do. Mostly the period is the big one that we're going to need. Now notice that the period, this function's period doesn't end until it's off the graph. You guys see that? But what I can see here is that this must be half the period, which is 6. So the whole period needs to be 12 then, right? Now what I'm going to do is I'm going to use my calculator to write the equation for this. So I'm going to find these 5 points. So 0, 4, 3, 7, 6, 4, 9, 1, and then 12, 4. Everybody's okay with how I read those points off the picture? So I'm just going to type those into a stat. So I'm going to do stat, and I'm going to type those points into my L1 and L2. Now that I've done that, I'm going to exit out. I'm going to press the Stat button again, but this time I'm going to go over to the Calc menu, and I'm going to scroll down through all of my regression equations until I get to the sine reg. So I'm going to pick the sine reg option. And now this asks me some questions here. The first question is the number of iterations. So it wants to know, like, how many periods did this thing happen that I'm giving data for. So how many iterations of my graph do I have here? Just one, right? Because I just have one full period made up by the points that I'm giving it. Sound good? I use my X and Y list that I just had. My period, I know, is 12. And I'm going to store that regression equation because I see in part C I need to solve this equation when it's equal to 3. So I'm going to save that for later. So vars, y vars, function y1. And I'm going to hit calculate. So out of this has spit my values for A and B that it needs to answer the question. Isn't that lovely? Yeah. Now keep in mind here, your calculator has to do this in the following way though. So the calculator is giving you an answer, assuming that X is in radians. So I would write, with my answer to B, I would write B equals 0.524 radians next to my answer. And now when I do part C, when I'm going to graph this to find the intersection, guess what I'm going to have to do? I'm going to have to move my calculator to radians mode for this problem. But that's not that big of a deal. I can handle doing that. It's much easier. I just have to remember to do it. It's easy to do. It makes this problem super simple. But I have to remember to put this problem in radian mode to do this. So then it asks, find the first time after 12 noon when the depth of the water is 3 meters. Give your answer to the nearest minute. So I want to solve this for 3. So I'll put 3 into y2. And then I'm going to set my window so it looks the same as this picture here. So I'm going to go, my x's are going to go from 0 to 9. And my y's are going to go from 0 to 8. Is everybody okay there? So I just changed the window to match exactly the picture. I hit graph. There's a nice check too for part A and B. Notice the picture I get looks identical to the thing that they've provided. So I'm pretty positive my answers for A and B are correct. And then I just need to find this point here. So second trace, intersect command, enter, enter, enter. And I get that the T is about 6.65. But notice that doesn't actually answer the question because it wants the first time after noon and then round that answer to the nearest minute. So in this problem, they were giving things in military time. Notice that? Because I think that's international standard. You could use PM. It'll be fine. So the way I would write my answer is I know that the T is defined as hours after noon. So the hours is going to be 6 plus 12. and the number of minutes is going to be 0.65 of an hour. And I know there's 60 minutes in an hour. So I'm just going to do 0.65 times 60. So I think that comes out to be like 1839, or you could write as 6:39 p.m. Ava, if you're more comfortable doing that, that would be acceptable also. You can use AMs and PMs, that's fine. So I think that your points for this part, there's 3 points here. That's 1 point. Writing the equation that you're solving in your calculator. 2 points is that value for t, and your third point would be converting that value of t into a time. But isn't that nice, doing that on your calculator? If you looked at, again, I wrote out a by hand on this. If you look at what I wrote, I had to remember a whole bunch of these little formulas on how to find like the A's and B's and stuff from my pre-calculus class. And if you don't remember these formulas, they're not in the equation sheet, which was why I wanted to make sure I showed you how to do it with the calculator, just doing a regression equation. So that's what I did here. You don't, if you use the calculator to do the regression, you don't need any of that stuff, which is why I wanted to show this to you, because I did it the by hand way. But if you don't remember these things, if you're like, I know we did this in pre-calculus or trigonometry or whatever, but I can't do it anymore, that's fair. But the calculator will do it for you. So all you need to do is pick out the key points, the midline points and the min and max, and then write down the number of periods. Probably just one period is fine, and the length of that period, and press enter, and remember it's giving you an answer in radians, and you're good. Now, really important, that now that we've finished this question, what do I need to do before I move forward? I need to take my calculator and put it back into degrees. Okay, so again, I did this by hand so that my answer would be in degrees, so I wouldn't have to change the mode of my calculator. But if you don't remember the formulas, your calculator won't do the regression with degrees in it, which is kind of stinky. You know what I mean? What you could probably do, let's see. Where is that menu at? Statistics, maybe. That was my B that we just made. If I multiply that by 360 over 2 pi, yeah. So Olivia, if you don't want to have to worry about changing your calculator mode, you could take your answer for B that you get and multiply it by 360 over 2 pi and use that number instead as your B, and then you don't have to worry about changing the mode of your calculator. It'll always be 360 over 2 pi. All you have to do is multiply your answer for B by that, and it'll give you a new B that is now in or in degrees, so you don't have to muck around with the mode on your calculator. If that feels better, you could do that as well. So it's 6 and 1/2 dozen the other. I think either should be fine. And in fact, when I look at the mark scheme, they give both the answers for B in radians and in degrees. Now, for the radian one, they do it in terms of pi, which your calculator will not do for you, but I think it's fine if you give the decimal approximation. I'm sure they'll take it. Okay. So again, this was 1 mark, just your A is 3. Calculator gives that. The mark for B gives 2 marks. The mark for work on B was that you acknowledged that the period was 12. So that's would have been the second point there. 1 point for the answer and 1 point for identifying the period was 12. So you needed that to find the B. So again, my work for parts A and B, I'd write down those 5 points. I'd write sign reg, and I'd write down the values for the inputs that I have. So 1 iteration, period is 12, and then write down my values for A and B that popped out of my calculator. And if you converted that to, multiplied the B by, 360 over 2 pi, I'd write that part down and, So I would just write down a little bit of the stuff that went into my calculator for my work there. Does that feel okay? And they've been pretty clear that calculator work counts as work. So if you write down what you're entering into the calculator and how you're doing it, that counts in this class, which is nice. Does that feel okay? So again, I did this the by hand method. If you remember how to do that stuff, or like you review it lightly and you're like, oh yeah, I kind of remember doing that, that's not so bad, that's fine. But I wanted to make sure to show you the calculator, how the calculator can take care of it for you. Also, because we didn't do any modeling problems because it's covered, we do it in trigonometry and there's just not time to do it again. And you guys by the end of the year weren't interested in having me cram another chapter down your throats. But it's fine, like the calculator will just do it for you. All right, you guys want to do some paper 2 problems, and we can always circle back after you've taken another pass through paper 1 next class and hit some of these ones we haven't talked about. What do you guys think? Sound good? Okay. Take a look at your paper 2 for me and let me know what you're interested in there. Really the difference between the paper 1 and paper 2, the paper 1 questions are all single topic. Like they're only the information that you need to do the question is only gonna come from like 1 chapter, 1 unit that we covered in class. The paper 2 questions might come from 2 or 3 units. So you might have like overlapping content and typically have much more parts, right? Like this first question has 19 marks to go with it, but it's got parts A, B, C, D, but all the A, B, C, and D have multiple parts to it. But there's less of these. There's only like 6 of these or whatever. Does it say? Whatever. So take a look through your paper 2 and see if there's anything that you guys want to talk about there. If you don't, I have one that I would recommend we talk about, which is question 2. This corresponds to like the normal binomial distribution chapter that we did after you came back from Christmas break, that everybody kind of pooped their pants on a little bit. And this is one where like all the setup is in your calculator. Basically, you're just going to write something down on your paper and use the calculator to execute it. So it's really important that you're able to do that effectively. so you're able to read what's going on here and know how to get it into your calculator. So number 2 says the company Fred Express delivers packages. From past experience, the time taken, T, to deliver a package follows a normal distribution with mean 64 hours and standard deviation 12 hours. State the probability that T is less than 64. So to use for this, if it's a normal distribution, we're going to be using one of 3 things. Normal CDF, normal PDF, inverse norm. Those are the only 3 things we could be using if it's normally distributed. So because this is a accumulation, we have all the times between 64 and negative infinity. This is a CDF problem. So to find those distribution commands, we're going to open the distributions menu. So second vars, and then we want normal CDF. In fact, you'll never use normal PDF in this class. You could use a binomial PDF. So negative infinity to 64. The mean is 64, and the standard deviation is 12. I hit paste, and I get 0.5. Now, did you really need your calculator to do this one? In a normal distribution, I know that 50% of it is below the mean and 50% is above the mean. This is just the half below the mean. So I could have done this without. So you could write 0.5, you could write 50%. Either is fine. The next one says find P of 44 less than T less than 64. So again, same idea. Normal CDF. 44 to 64. Press enter. I'm getting 0.5 or 0.45. 2. I wonder what the extra mark is available there. Let's see what that's all about. What they gave that extra mark for. A little surprised that's a 2-mark question. It's just 2 marks, I guess. That's weird. Okay. Whatevs. Is everybody okay so far? It says 30% of packages are delivered in less than K hours. Sketch a diagram of this normal distribution, shading the region that represents P of T less than K. So what does a normal distribution look like? Oops. Yeah, the bell curve. Excellent. So I do that. I'd label 64 here. K has to be left of 64. And then I would just like shade that part of it and maybe do that. But that should be sufficient. Is everybody okay with how I drew the picture? No big deal, right? It then says find the value of K. So if I want something inside that probability, what command do I need to use on my calculator? Inverse norm. Need to use inverse norm if I'm solving for the piece inside. So I'm going to use inverse norm. The area is 0.3. The mean is still 64. And the standard deviation is still 12. So I would say 57.7 would be my t. What's the one thing you have to remember about the inverse norm? It can only do it for less thans. Okay? So if your probability isn't set up as a less than, you have to manipulate it so that it is a less than. So like if I had P of t is greater than k, well, that's the same thing as 1 minus P of t less than or equal to k. And less than or equal to doesn't matter for a continuous distribution like the normal. It does for binomial, but not for normal. So that's how I would do it if it was like a greater than. Is you just have to do like the complement. Again, worth talking through because this was a while ago and this was our first unit of this semester and it didn't go particularly great, the test did. So I wanted to make sure we talked about this. Paper 2, you can have ideas coming from multiple units in the same question. So typically the questions are longer and more involved. Paper 1, the questions are coming really from a single unit. And they're less involved. It's longer, but it's like, I think it's more straightforward.
And there's no multiple choice.
There's no multiple choice anywhere. I have no clue, not for math. All right. Continuing on in this question, it says, for quality control, the manager randomly selects 5 outgoing packages. These selections are independent. Find the probability that exactly 2 of these packages are delivered in less than k hours. So what type of distribution is this now? Okay, this is now a binomial distribution because it's either they're delivered in less than k hours or not, right? The sampling is independent. The probability stays the same. You know, this is binomial. So the probability that n is equal to 2 is what we're finding. So what type of binomial are we going to be doing? If I look at my distribution list, I go down and look at my binomials. Do I want PDF or CDF if it's equal to 2? Equals means PDF. Inequality means, well, strict inequality is CDF. So the number of trials, how many packages am I selecting from? Tells me in the problem 5. The probability of less than k hours was 30%, so 0.3. And I want to see if x is equal to 2. So 0.309. Okay. Next part, it gives us a little bit more. It says Fred Express charges a fixed amount of $4.50 for any package weighing 1 kilogram or less. Heavier packages are charged an additional fee of $2 per kilogram. This fee is applied for any weight in excess of 1 kilogram. For example, a 1.5 package is charged an additional 1 kilogram. Or is charged an additional $1. Right, so notice that the 0.5, we're just multiplying it by 2 to get the $1. It says, write an expression for the amount charged to deliver a package of weight X, where X is greater than 1. So we're going to have, I'm going to write a function, charge of X is equal to, we have the fixed amount, and then we'll have our variable amount. So how much are we charging for the additional kilograms? $2 times, but it's not going to be X because it's the amount in excess of 1 kilogram is charged the additional fee. So the additional fee should only apply to X minus 1 kilograms of package, right? So that's it. Just fixed cost plus variable cost gives us our total costs. The cost for a 5.3 kilogram package, just plug it in above. For charge 720, find the weight of the package. So there we would just set the 720 for the charge and solve for X. And again, those are relatively easy algebras. The hitch is that if you didn't get the expression right, you weren't going to be able to get the right answers. Let's look at the mark scheme on that. So it looks like you get a point on part G there if you just take your answer from part E and set it equal to the value, even if your answer for part E is incorrect. And it's possible if you royally boogered part E or used X instead of X minus 1 and you still did these, I think it looks like they're going to give you the full marks for parts F and G, even if you had the wrong answer for part E, as long as it was x instead of x minus 1, if I read this correctly. Sometimes it's a little bit cryptic, though, to figure out what they mean on their mark schemes. So the big takeaway from this question is making sure that you know when to use a normal, when to use a binomial, and how to use those commands on your calculator. Notice that like none of those questions were super duper complicated, but you had to know like which command to use when. You feel okay, guys? I'm going to stop here because you guys are clearly feel like you're cooked here for today. Try to look things over a little bit more between now and next class. Come back with, some specific things you want to talk about. We can talk about more, go through details on. There's one other thing that I want to mention that while I'm thinking about it. Before this test, they are going to make you reset your calculator's memory, which is fine. They'll give you the instructions to do that. After they do that, though, you need to do two things immediately. Number one, put your mode to degree. And number two, you need to turn the diagnostic back on so that the R values show up when you do your regressions. To do that, you press second and then the 0 command to open up the catalog. You can press X to the negative 1 to scroll to the D's, and then go to diagnostic on, press enter. When it says done, you're good. But immediately after you reset your calculator's memory, you should do those two things. Put your calculator back into degree mode and turn your diagnostic back on.
So it's second 0, x minus.
Yep. And again, like even if you forget that part, Henry, you can just scroll till you get to the D's. If you use the letter D, it'll skip just to the D's and then it's less typing. But it doesn't matter, that part. As long as it's second 0 and then diagnostic on, however you get to the diagnostic on is fine. But you need to remember to do that because there will be questions, like you don't have enough time on the test to bother calculating R's by hand. Like you should not be doing that.